Welcome to Goldfish on Games, where today I'm going to be fulfilling a promise I made over 3 years ago, as we return to the Amstrad PPC640. For those of you that haven't ventured that far back in time, we checked out, cleaned up and then did some limited upgrades to this machine, the Amstrad PPC640. Now this is an 8088 class portable computer that used the NEC V30 CPU running at a whole 8 MHz. It has 640k of RAM, a 2400 baud modem, CGA graphics and 2 floppy drives, one of which has been upgraded to a HXE flashed Gotek. There's no internal hard drive or even basic support for one. So what are we going to do with this machine now? Well, in the last 3 years, a number of developments have happened. I've personally learnt a lot, as well as gotten a little bit better at soldering, but to be honest, the more important thing has been the hobby circuit board design and printing scene has absolutely exploded, which has resulted in this being designed, an expansion board for the PPC. Now this was designed by Eric Murphy of Retro Theory, and has released it on GitHub for anyone that wants to get it printed up. I'll include links to both the GitHub page as well as his YouTube channel, as there are a number of great videos on this machine that are worth checking out, and he's shown a few upgrades that I'm actually quite interested in trying out myself. Now this board was actually provided by a viewer called Gary, as he enjoyed the other PPC videos, so a big thanks to him. And as you can see, I've already partially built this one, and when fully built it can actually provide 3 8-bit ISA slots to the PPC. Now this is actually connected via 2 ports on the back of the machine. The expansion ports labelled A and B, and if we check out the port schematics and that of the 8-bit ISA slot, we can see that it actually provides every single line needed to make this work. But there are 2 important bits to note. The data pins are not buffered, and that the power pins are technically inputs into the PPC, not outputs to the board. But we'll come back to that in a little bit, as this board was designed with both of those things in mind. The buffers can be found here, in these 2 chips, and these are pretty much to make sure that the length of cable isn't a real problem, though I think if it is too long it still can be. And there's points on this board that you can solder an ATX power connector and thus power the whole machine via this board, but as you can see I've not done that. And the reason for this is that the PPC will provide power over those pins if a single one is not connected, which is pin 20. So if you actually provide power over pin 20, the PPC will actually turn off its internal power circuits and expect to receive all of its power requirements over those connectors. So I ended up cutting both pin 1 and 20 from this ribbon cable, as thankfully pin 1 is just a 5V line, and the other connector also provides 5V as well, so it's not quite as needed, and it was just easier to cut both of them than just one. In theory, everything I plan to connect to this shouldn't actually use all that much power, so it wouldn't be putting too much strain on the internal power supply, as normally this thing would be spinning multiple floppy drives and possibly even the modem at the same time, but there was an upgrade that could add a hard drive. Now this was a 3.5-inch mechanical drive that would take up the space of one of the floppy drives, and the hard drive controller would actually replace the modem, which seeing pictures of it looks like a right bodge job, but it does give us an idea of how much power this thing can draw. What I plan to run is this compact flash hard drive and this AdLib compatible sound card. Both are pure 8-bit devices and very small, which will be very important later. So let's get this set up and check them out. This card is the XT-CF Lite board and is based on the XT IDE and has the universal BIOS enabled, as this machine has no idea about hard drives, so there's no built-in controller at all, so this card has to double as both the IDE controller and the drive. So let's start up the machine, and it goes through the normal boot setup with it asking us to wait. I'm actually using a 1GB card. It was one of the few that I found that was fully compatible, but I can tell you it's not using all that space, as I copied over the DOS from the PPC discs. With the beeps it tells us it's missing the date and time, but then it goes to show the Uni BIOS, which detected the compact flash card And before we know it, we have to skip over those date-time inputs, and we're at the regular DOS prompt. As we can see, the listing of files is all nice and fast. Well, you would if this screen wasn't so blurry. And even with the UniBIOS, it still booted faster than from the floppy disk. But we will need to switch back to the floppy for us to test out the sound card, which is the internal OPL3 FM for the PC XT and was designed and built by Spark 2K06. As you might have guessed from the name, this is an internal sound card. There is no bracket or audio jack to be found on it. Instead, there's just this header that follows the standard HD audio spec. This means we need to connect pin 5 and 9 for left and right audio, and then pin 2 for ground, which we can do via this very ugly looking cable, which, trust me, is only going to be used for testing. So let's connect it to the sound card, then connect that to the expansion board, again making sure it's the right way round. We don't want to break anything here. So let's give Slip Heed a go, and after getting past the boot screen and the Emperor of the Universe talking via the PC speaker, we get into the game proper and just listen to that ad-lib music play. The sound effects are still being provided by the PC speaker, so let's just turn that down for now, and we can tell that this is actually sounding quite nice. It does sound so much better than it looks on this screen. The audio quality seems to be quite good, even though I have gotten a lot of noise in the past, which I think might be more down to my dodgy building skills than anything else. The next step is to obviously run both the hard drive and the sound card at the same time, but that will require some extra work to the board. Now you might have noticed I only had one slot fitted, and that was just so I could test everything out first to make sure it was all working. And with the first step over and done with, which was testing everything out, we move on to step 2, which I'll need to modify the board to do so, which means it goes from this to this. And what has changed? Well, there's now 2 right-angled ISA slots, which meant some of the capacitors had to move as well, and they were relocated to the other side of the board. Making sure they were the right way around was very important, as well as a bit of a pain. And with this current setup, I can connect the XTCF to the first slot, which has been angled to avoid the third slot, which gets the ad-lib card. And after connecting all the cables and starting the machine, we can see it detects the drive, and it boots. And as it boots, we can see the LED flashing away as it reads the card. And if we check the games directory, I have a few here that are ready to test. So let's boot up Prince of Persia, which has some nice ad-lib music and uses the internal speaker for sound effects. And with everything running nicely, it's time to unveil the end goal, as I want to put this whole thing inside the PPC. That's right, I want to have it internal. And to see where this is going to go, we need to open up the case, which comes away easily enough if you're careful of the battery and PC speaker cables. The place I want this upgrade to go is here, the space currently taken up by the dial-up modem, which simply unplugs from the board As we can see, there should just be about enough room if we trim the expansion board down. This goal has been on my mind ever since I spotted this board, so it's going to be interesting to see if it all works. To aid with this process, I actually have a spare expansion board, which I've used to make a cardboard template. And from this template, I've cut away what I think I can safely remove from the expansion board. And as we can see, there is a bunch of space that has no traces. So with the template, we can see it should just about fit nicely in the space, but the proof will be in the actual doing. But I want to do two things before I touch the built board. The first is to remove the modem from the machine, which requires taking off both main boards, which means unscrewing a whole bunch of screws and taking off these plastic pegs. The bottom board is also connected to the floppy drives, so there isn't too much slack to deal with when trying to move it. But with them both out the way, I can unscrew the holder that's keeping the modem cable in place. With that gone, the cable is pulled through and it's gone. The next step is to do a test cutting on the spare expansion board. Now this is important as I need to make sure I don't cut any traces. But there also needs to be a notch taken out of the board, as you can see on the modem, and this is to allow the case to sit correctly, as there's a bit of extra plastic on the case. I'm also hoping to add a screw hole, as I think it'd be good if it's held down at least some way, and so it's not rattling around. So I've been putting this off long enough, all that's left to do is to get out the Dremel and try cutting it down. Now you might be wondering why I didn't just trim down the board to make sure it all fitted and then built the card. Well, that would have been smart, and I don't actually have a good answer to that. The other option would have been to redesign the board so it fitted, but I don't have the experience of designing boards, so that was out. So instead, you just got me plunging my way through this, hoping it's all going to work. And with the test cuts complete, we can see how it fits. And to my surprise, it actually feels like a perfect fit. I'm actually a little bit surprised about how well it sits in there, to be honest. And looking closely at the board, I did get a little too close to some of the traces. Thankfully this one isn't actually needed as the power connector isn't wired up, but I do need to be more careful with the real board, which I will get to after I cut out the tab, as that's the next thing I need to test. And after a bit of measuring and eyeballing, a hole is cut, and amazingly, the case seems to fit nicely around it. So I guess all that's left now is to take the plunge and cut the main board. And tell me, do you think this worked? Just look at that. Just look at how well that fits. And if we pass the cables out the hole that the modem used to use, we can hook it all up and start it up with everything being internal. Well, apart from the cables, obviously. And the hard drive boots up just fine, and let's start a game, and it's also working great. Now having those cables dangling out isn't a great look, and it actually makes it hard to close that flap up when you're trying to put it away. So let's instead try to hook up the cables internally. And here we can see one of the expansion ports that I've already soldered up. That's 36 pins out of 37 done, as we skip pin 20 like before. And this required splitting the cable, stripping it, tinning it, and then finally soldering each of those to the pins. Now you have to be careful to check which is pin 1, and then you need to make sure to alternate between the top and bottom row. This is easily the worst part of the project so far, and it's also the one I expect to screw up with the most, as my soldering skills are not all that great. And with 62 pins in total, I'm expecting to make a mistake. And with the last one complete, we can now use some electrical cable to keep everything in place and give it a go. I'm sure you're starting to get bored of seeing this boot up sequence, but it does seem to boot up quite nicely, which is always a good step. And let's start again. Why no sound? Oh! It helps if you actually remember to plug the audio cable in, doesn't it? And with that done, it is sounding pretty good. With this all sounding and looking pretty nice, it's time to do another check to make sure it all fits together. And with a bit of finesse, and making sure that the ribbon cable isn't covering any of the screw holes, it does. So this is actually looking pretty damn neat. I am actually quite tempted to leave it here, as I've done exactly what I set out to do. The machine has a hard drive and sound card internally, and all with no extra power. But I think there's one area that needs a little bit extra polish: the audio, as having a cable dangling out the back isn't the best solution, and I just know it'll end up getting lost inside if I don't do something about it. There's also something else that I want to try out. So let's get that back off it again. Now what would be nice is if we could pipe the PC speaker audio out into the AdLib card. Now this turns out to be possible. And if we look here, this is a 3-pin jack. And the cable for this goes to the volume dial. And these 3 pins have the PC speaker audio out, a ground cable, and a PC speaker audio input, as this dial is directly working on the audio generated by the machine to change the volume. So if we plug a simple wire to the audio output on this header, and put it in the mic input on the AdLib board, which should give us mixed music and sound effects, and the only way to test it is with a gain. And PX3 actually makes for a good choice for this, as its boot menu lets you select between PC speaker and AdLib. So let's go with PC speaker. And we get that bleepy music, which is sounding pretty great, at least for PC speaker music, but it does mean the internal speaker is currently dead. But we'll come back to that in a minute. For now, let's switch to having AdLib and PC speaker at the same time. And that's also sounding pretty good, so let's see what we can do with that internal speaker. The first step is to get rid of the ugly cable and replace it with this, a standard 3.5mm audio jack, which I've soldered 3 cables to it that have standard headers on the other end, and those just connect to the card as before. Now this audio jack has 5 pins. 2 of them are effectively being outputs. As the internal speaker is mono, we need to solder 2 resistors and tie them together that should result in mono audio. These are then piped to the input of the volume wheel, and those 2 other pins on the volume wheel are then connected back to the Mobo using some standard cabling. And so let's see if we got it. And there we have it, audio coming out of the internal PC speaker. Which I can actually change the volume with the wheel. Now in theory, those two pins on the audio jack should be cut off if I insert a headphone cable. And while we can tell the external speakers are working, there's still some sound coming from the internal speaker. But if I wiggle the cable slightly, I can feel the sound cutting out, which makes me think this is a pretty cheap and badly made part. It works, but I might have to try and replace it later, or try fixing it up. You might have noticed that I never showed Slip Heed again, as you might have thought that would have been a great example of ad-lib music and PC speaker sound effects all together. And there is a reason for that. I have this weird problem that when I have both the OPL3 card and the hard drive connected, the ad-lib music just gets corrupted, and it starts playing all the wrong notes. And it's not the copy of the game, as I tried both the installed version and the one from the GoTech, and even tried changing the address that the cards are running on. Absolutely nothing worked. And it's odd, as all the other games sounded absolutely fine. So I can only assume there's some weird compatibility issue between the game, the sound card, and the hard drive. Now it's not a deal breaker for the machine, but it is a bit of a shame as this game has some great music. And there we have it, that's pretty much the core work done. Now I've done a few extra little bits and pieces, like made a little backboard for the audio jack to sit in, which is just some cardboard that's been spray painted. But I think it looks pretty good if I do say so myself. This has been an amazing project, as the end result I think is great. It looks stock, but has some wonderful upgrades. This has been a project that I've been thinking about ever since I did that first video over 3 years ago, but this attempt mostly came together in just the last 4 months, and I can tell you, this was easily one of the most expensive videos I've ever done. But I think the end result is so good that it was worth it. While there might be still some great upgrades that you can do, I think I might leave it there for this machine. And if you're interested in seeing what else can be done with the PPC, then I suggest you check out Retro Theory, who's done some interesting videos on the machine, as well as Noel's Retro Lab, who put a colour LCD inside of it, and that was pretty cool. So until next time, I've been the Goldfish, that is turning into quite the laptop, and this has been Goldfish on Games. Thank you for watching my video, I do hope you enjoyed it, and if you did, you can let me know down in the comments, or you can use those buttons just below, you know the ones I mean. Or if you're not sure yet, then you can check out 2 other videos that I've done that are on the screen right now. So thank you again, and I hope to see you soon.